Alright guys, welcome back to another Math Notes video. This is 6.1.1, Forms of a Linear Function. We're going to go over three types of linear functions today and talk a little bit about how to transform equations from one to the other. So first off, there's three main forms of a linear function, and it's important for you to know all of them. The first one, and probably the most common that you're used to, is slope-intercept form. Then there is standard form. And lastly, point-slope form. All of them have their little subtle advantages and disadvantages. Let's take a look at them. So, slope-intercept form, like I said, is the one you're probably most used to. That's the good old y equals mx plus b, where m is your slope and b is your y-intercept. The next one is standard form, which takes the form of ax plus by equals c. So an example of that would be something like, 2x plus 3y equals 4. That would be the standard form of a linear equation. We have whole number coefficients in front of the x and y, and it's equal to a constant c. Some books will also denote this as they'll subtract the 4 from both sides and will give you something like this and make it equal 0 for standard form. This book has it equal to the constant rather than equal to 0, but they're sometimes both considered standard form. All right, point-slope form is y minus k equals m times x minus h, which sounds confusing, but it's really not that bad once you get used to it. So the slope is m, h and k is a point on the line, any arbitrary point on the line. For example, if the slope is -7 and you're looking at point 20, -10, then the equation can be written as y minus -10, because remember this is h, this is k, so we're going to come in here, we're going to plug in -10 for k, and we're going to plug in 20 for h, and we're going to get y minus -10 equals -7 times x minus 20. And after you take care of your double negative there, you get y plus 10 equals -7 times x minus 20. I'm going to go ahead and add for point-slope form that it's a little easier to remember this if you know where it comes from. It comes from the slope equation. The slope equation says that m equals the change in y over change in x. So change in y we could label as y minus y1. Change in x we could do as x minus x1. And then if we multiplied both sides of that equation, x minus x1, we end up with the slope times x minus x1 equals y minus y1. And then here's our slope. And these are the x1 and the y1 are the coordinates of the point that we're going to plug in. It looks a little different than the one they gave you because they've called what I have labeled as y1, they've called k, and what I have labeled as x1 they've called h, which fits up with the other mother functions a little better later on as you go through those. But really it's a rearrangement of the slope equation. So again, if we have m equals y minus y1 over x minus x1. When we multiply it, effectively what we're doing is moving it over here. So that gives us the other form of the equation. Just like that, and that gives you the equation. Alright, let's go ahead and talk about changing forms of the equation. I'm going to start with the one that they left us off with right here. Y plus 10 equals -7 times x minus 20. That's in point slope form. If I wanted to put that into slope intercept form, I would just distribute that negative 7. I would get negative 7x plus 140 equals y plus 10. Then I would subtract 10 from each side. That's a 0. Equals negative 7x plus 130. And now I have it in slope-intercept form, where that's my slope, and that is my y-intercept. If I want to turn that into standard form, well, I just need to take my slope-intercept form, y equals negative 7x plus 130, and move the 7x over to the other side, so that now I have 7x. I'm just going to fix that. 7x plus y equals 130, and that would be the equation in standard form. Alright guys, and just for fun, I've gone ahead and plotted those three equations in the different forms all in the same graph here in Desmos. So you can see that they are in fact the same line. They all line up with each other. Here we have the slope-intercept form of the line with its y-intercept there at 0, 130. Here we have the standard form of the same line, which is underneath there, so if I want to show it. Standard form of the same line. And finally we have the point slope form of the same line, all of them on top of each other. Alright guys, I'll see you next time.